associative, dissociative, uniting. So today we'll continue with that. Okay. So today we'll go for the remaining laws. So next in the line is absorption law. So as per this law, your x plus x dot y will be equal to x. So let us prove that x plus xy. So what is your distributive says? Distributive says that what is distributive? X dot y plus z is same as x dot y plus x dot z, and its dual is x plus y dot z is equal to x plus y dot x plus z. Okay, so here uh, I can take, I can apply that rule, I can apply this rule, yes or no? X plus y dot z. So as per this, it has to be x plus y dot x plus z. So यहाँ पे क्या हो जाएगा? What I can write here for that?
x into 1 plus 1.
X plus 1.
No, x plus 1 नहीं होगा डायरेक्ट ना. Check it again. फॉर्म में क्या है? It is in the form of, I think, in terms of this a plus b dot c. Okay, so what can we write for this? We can
Plus
write
b
this
dot
at
A plus B dot A dot
a plus b dot
A plus.
a plus c. Okay, so similarly, what we can do here? We can do that x plus x dot
x plus y.
y. Okay, now x plus x is what? X plus x is how much?
X.
One second. One second. Okay, well, let us not go through that. Let us directly take
Want
that.
to take x common.
We can take x common. If we'll take x
And that's
common, we can write that this is equal to, this is nothing but x dot 1 only. X dot 1 is equal to x. So from that we can write that this is equal to x dot 1 plus y. So how much will be 1 plus y? If we add something with 1, logical addition will be 1 only. So this will become x dot 1. Again, x dot 1 will be always equal to x. Okay. So as per the absorption, x plus x dot y, that means any variable plus that same variable dot any other variable will be equal to that x. Okay. So its dual is also true. No need to prove it. Its dual will be, how we can get its dual? Just by interchanging dot with plus, 1 with 0 and 0 with 1. So here x plus x dot y was equal to x. So its dual will be x dot x plus y will be equal to x. Okay. Next is redundant literal rule. Redundant literal rule. So as per this theorem, what will happen? Your x plus the variable plus its complement dot any other variable will be same as x plus y. So basically this can be removed. Okay. So let us prove that. So what we can do now? Here we can go for that distributive. We can go for the distributive. It is in the form of a plus b dot c. What is a plus b dot c? A plus b dot c is a plus b dot a plus c. So in this expression, what is a? X is a, b is x bar, y is c. So LHS, if we apply distributive, what can I write?
X plus X bar
X plus
dot
X
X
plus x bar dot
dot x
x
plus y.
plus y. But x plus x bar, this is always gonna be equal to 1. So
Yes.
this will be equal to 1 dot x plus y. So x plus y dot 1 will be always equal to x plus y only. So this is called as redundant literal rule. Once it is proved, its dual is also proved. So what will be dual? just plus needs to be replaced with dot, dot needs to be replaced with plus. So dual will become x dot x bar plus y will be equal to x dot y. Okay. Next important one is consensus. Next one is consensus. If you don't remember these things also, by doing 1 2 step, you'll be able to find the answer. Okay. So this will not be that much of useful, but consensus is very powerful. So what happens here? See, x dot y plus x bar dot z. So what happens here? Here I took a variable in the first term. This variable is there. Second term, that same variable's complement is available. Okay. So what are the other variables used? Here y is used. Here z is used. So plus product of this two, which is yz, will be equal to x dot y plus x bar dot z. Again, I am repeating, some variable in first term, this variable is present. Second term, its complement is present. Okay. What are the remaining variables? Here it is y, it is z. So in third term is addition of those, multiplication of those and operation of those remaining variables, which is yz. Okay. So this will be equal to xy plus x bar dot z. So with the help of that, what we can do, if we have this three variables, sorry, if we'll have this three terms, we can reduce it to two terms depending upon our need. I can remove this term, or depending upon this, if I have this two, I can add this also. So depending upon our requirement, either we can remove or we can add this term. If we have this RHS, we can add this YZ. If we have this LHS, we can remove this YZ. So that depends upon our requirement. Okay. So for that, I need to prove it. Okay. Let us try to prove it. So can I write like this? Xy plus x bar dot z plus, in place of yz, can I write like this? 1 dot y dot z. Will it be okay? If we
Yes.
take AND operations
Yes, sir.
with 1, we know that a dot 1 will be always equal to a only. Okay. So a is nothing but yz. Now, we know that 1 is nothing but a plus a bar. 1 is equal to any variable plus its complement. So in the next step, in place of that 1,
X plus
I
X bar.
can x plus x bar. Okay. Next step, I can apply the distributive. This is x plus x bar dot yz. So if we'll apply distributive, what will happen? You will get xy plus x bar dot z plus, what can I write? I can write that this will be equal to xyz plus x bar yz. Now check first term and third term. Can you take something common in first term and x? Only x.
XY.
We can take xy common. So if we take xy common, this will become xy dot 1 plus z plus second term, fourth term. We can take x bar z common. If we take x bar z common, this will become x bar z into 1 plus y. So what is the value of 1 plus z?
1.
This is equal to 1 only. Similarly, 1 plus y, this is also 1. So xy dot 1 is same as xy, okay, plus x bar dot z. So what happens? So with the help of this theorem, we can remove this third term. We can remove this third term. Once it is proved, its dual is also proved. What will be its dual? Xy dot will be replaced with plus. So x plus y, then plus will be replaced with dot. X bar plus z, plus is replaced with dot. Y plus z will be equal to how much? X plus y dot x bar plus z. Here though we don't have zeros and one, so just we need to replace plus with dot and dot with plus. So this theorem is proved. Now let us go for another question. Now suppose here apart from yz, suppose I will write a. So will this be expression be true? Just see this derivation and try to find out. Apart from yz, if some other variables will be there, then will that expression be true?
Yes, sir.
It will be
Yes.
true. Why? There won't be any effect. Here a will come, here a will come. So let me take another color. So here this will become a, this will become a. So once you take xy common, this will become j dot a. Yes. So this will be same as 1 only. If you add something with 1, result will be 1 only. So if it is only a or some other variables come here, still the result will be same. You can remove that third term. So what is the requirement? Requirement is how can you identify any variable in the first term, second term its complement will be there. Apart from that, whatever else is here, y, z, third term its product has to be there. Apart from this, something else will be there. Now suppose instead of y, suppose z is not there, abc is there. Okay. Then it will, can we get this expression? No, it is not possible. It will not be same. So mandatory thing is this product term, this remaining variables has to be present in the third term. So in this example, y is there, but z is not there. Okay. Next theorem is transposition theorem. Transposition theorem. So as per this theorem, your x plus y dot x bar plus z will be equal to x dot z plus x bar dot y. So let us try to prove this. So can you prove this? Try to prove this one. Try to prove this one. It will only take 1-2 steps. What will happen? If you solve this LHS, if you open this, it will multiply. What you will get? क्या आएगा? Anyone?
X bar plus
X
x z
bar plus x dot
x
z
z
plus
plus y dot x bar plus y z
what is x dot x bar?
1.
0.
Not 1. Any variable and its complement is 0. This will be 0.
Yes.
So 0 plus something is that remaining result. So no need to write this. So how much remaining? Remaining is x dot z plus x bar dot y plus yz. So it is nothing but consensus theorem only. It is x is available,
Yes.
here x bar is available. Remaining is yz. Third term yz is present. So we can remove that. So this will be x dot z plus x bar dot y. Okay, so this is transposition theorem and its dual is also correct. So why we learned all these theorems? Okay, now to understand this, first go through this expression. Suppose j is given this much. Now, if we think about it, okay, so what kind of logic gates will be required to implement this function, Boolean function? What kind of logic gates will be required to implement this? See this expression and tell
And or not.
and or not. Okay. So suppose AND gate. How many AND gates? How many AND gates will be required?
15.
कितना?
Four.
Not 4. 5 terms are there. If I have 3 input AND gate available with me, it will take 5 AND gates. Okay. 1, 2, 3, 1, 2, 3. Okay. So I'm not going through the NOT gate. Okay. It will become messier. Okay. So for the time being, I am ignoring NOT gates. So for this first AND gate, inputs will be A bar, B, C. For second one, this will be A, B bar, C bar. Third one's input will be A, B bar, C bar. Fourth one, A, B, C bar. Fifth one, A, B, C. Apart from this, what we want? We want OR gate. So if I have a 5 input OR gate available with me, then this will give me the output expression. Okay. So in this way, we can implement this function. Now, how many total number of gates were required here? If I will just remove those NOT gates are also required. Okay. So here A bar required, B bar required, C bar required. So for the time being, exclude that. Okay. Now tell how many gates are required here, excluding NOT gates.
6.
6.
6 gates are required. That too having different inputs. Here AND gate is having 3 inputs and OR gate is having 5 inputs. So remember, if this cost of your circuit will increase, obviously, if more number of logic gates are used, more logic gates are used means more costly it will be. More components are required, so it will be more costly. And also here it will also depend upon this number of inputs. It is not that we are using suppose one AND gate having 5 inputs. Okay, suppose instead of that we'll use 2 OR gates. So it is not that it will be this one we are using 2 OR gates, but still it will be better as compared to this one because here number of inputs are less. Here 5 inputs are there, here 4 inputs are there. Okay. So we are not going into that much of complexity. So the simple point here is more I need to spend more money to implement this kind of circuit. So if somehow if I can reduce this expression, then I will be able to implement this with lesser number of logic gates. That is the idea. So how we can reduce the expression? With the help of all these theorems. All these axioms and theorem will be able to reduce the expression. So let us try to do this. Let us try to reduce the expression of this and let us see how it will be helpful for us. Now see this expression, check any theorem will be able to apply. Now check the second term and third term. Can I take something common?
Yes, sir.
AB dash.
AB bar can be common. If I will take AB bar, this will become C bar plus C. Okay. Similarly, check this fourth term and fifth term. I can take AB common. If I'll take AB
Yes.
common, this will be C plus C bar. Okay. But C plus C bar is equal to 1. So this will be AB dot 1. This will be AB bar dot 1. Okay. So AB dot 1 is nothing but AB. AB bar dot 1 is nothing but AB bar. Okay. Now, can I take anything common? If you check second term, third term, I can take A
A.
common. If I'll take A common, this will become B plus B bar. Again, B plus B bar is equal to 1. Okay, so this will become A. So now we have with me A plus A bar dot BC. Okay, so it is in the form of X plus X bar dot Y. So which theorem I can apply?
Redundant literal.
Redundant literal rule. As per that, what we can write? We can write this as X plus Y. This one. Redundant literal rule. We can write this as X plus Y. So, here A is available, its complement, and this is your Y. So what will happen? This will become A plus B dot C. A plus B dot C. So now, previously we were using 5 OR gates and 1 AND gate. Okay. Now, by reducing this expression with the help of the theorems, the same Z now will be equivalent to A plus BC. So how I can implement that A plus BC? I will be requiring one 2 input AND gate BC, then I will require a OR gate which will give me A plus B dot C. Okay, so its implementation will be easier and its cost will be less. It will be cheaper as compared to implementing the same function. So as this is same as this, why we're gonna implement this one? This will be easier and cheaper. So we'll go for this one. Okay. So in this way you can reduce the Boolean expression. So many questions are available in your textbook. Okay. Or in other books also so many examples are available. So try to solve many questions. Okay. Try to minimize the expression. Whatever theorems you have studied. Okay. According to that, you'll be able to minimize that. Let us try to solve another one. Now, this function is given. We need to minimize this. F is given as A plus BC complements, its whole complement, dot AB bar plus ABC. Okay. Now, if I want to simplify this, first of all, here I need to apply the De Morgan's theorem. What is De Morgan's theorem? We know that x plus y whole complement is equal to x bar dot y bar. So what will happen to this? क्या हो जाएगा? Here x is a, this will be a complement dot. What is y here?
BC.
Not BC, BC complement. So this will become BC double complement dot. Here, can I take a common here? If I'll take a common, this will become b bar plus b dot c. Okay. Now, what happens here? This becomes a bar. This double complements cancel each other. Okay. Now, it is in form of b bar plus bc. B bar plus bc. So, which rule we can apply? We can apply same redundant literal rule. It is in the form of x plus x bar dot y, which is equal to x plus y. So, what will happen here? Here, what is your x? If you compare this, and this, what is your x?
B bar.
B bar. Your y, it's c. So what will you get? You will get this as a dot b bar plus c. Okay. No need to solve it further because here it is a bar dot a. So a dot a bar is there means anyway
0.
your product will gonna be equal to 0. It's gonna be 0. So this expression is reduced to 0 here. Okay, so these are easier. Next one, this is little bit tricky one. Okay. So when consensus comes into picture, it will little bit be tricky. So check next. So question is prove that LHS is equal to RHS. This is equal to this. So check this expression and tell what is the difference between LHS and RHS.
A bar, B bar missing.
A bar, B bar is, so which
Missing.
term? First term is missing. A bar, B bar is missing. All others remain same. So from here, you can know that whatever we studied, whatever theorems, okay. So where we can remove one term with the help of the consensus theorem. What does consensus theorem says? It says that x dot y plus x bar dot z plus y dot z is equal to x dot y plus x bar dot z. Okay. So check in this expression, can I apply consensus theorem directly such that directly A bar B bar will be removed? That means A bar B bar should be what? It should be your YZ. Okay. So check any term 1, 2, 3, 4 where I can apply directly consensus theorem. Anyone? Or randomly check. Just find out three terms where you can apply consensus theorem such that A bar B bar will be removed. Okay, let me write B bar C bar plus C dot D. If I'll rearrange, let me rearrange and write C bar B bar plus C dot D. अच्छा उसको उस तरह पे लेते हैं. So here I can apply consensus theorem. Here I can apply consensus theorem. But with the help of that, what I can remove? I can remove B bar dot D, but that is not the target. What I want to remove? I want to remove A bar dot B bar. But if I'll apply consensus theorem to the second term and fourth term, what can I remove? I can remove B bar dot D. So it is not possible. Now check third term and fourth term. If we'll write accordingly, this will be D dot C plus D bar dot A bar. Okay. So using, if I'll apply consensus theorem here, which term I can remove? What will be YZ here?
A bar C.
A bar dot C. But again, that is not my target. A bar B bar is my target to remove. That is not my target to remove A bar dot C. So here we observe that directly we are not able to apply consensus theorem to remove this A bar dot B bar. A bar dot B bar. Okay. So what to do? We need to add something. We need to add something such that we can apply consensus theorem to remove this A bar dot B bar. Okay. So what to do? Now observe this. Check this one, green color, B bar C bar plus C dot D. Okay. So if I'll apply consensus theorem here, okay. So who will be my X? C is my X. Okay. And Y is Z. Sorry, Y is D. Z is B bar. So by applying consensus theorem, I can add that YZ term. What will be YZ? YZ will be B bar dot
B
D.
bar D.
Okay. Now once we have with us B bar dot D, now we can apply consensus theorem here. Check this green color ones. Okay. So I can write like this. D dot B bar plus D bar dot A bar plus remaining is A bar dot B bar. So by applying consensus theorem, it is X dot Y, X bar dot Z. It is YZ. Okay, उल्टा हो गया. इसको B bar A bar कर देते हैं. Okay. So now with the help of consensus theorem, we can remove this term. That is our target. Our target was to remove A bar B bar. So by adding that term B bar D bar, we will be able to remove this. Okay. So by removing this, now what we have? Now we have this fourth term. Okay. So in RHS, what we want? We want this three. So which term is extra? Which term is extra here now? Which term is
A bar D.
B bar D? So the same way we included this B bar D, in the same way we can remove that also by applying consensus theorem. So what to do? Again we'll apply consensus theorem to these terms. B bar C bar, C D, B bar D. So let me write that here. So what will happen here? If I'll write, this will become C dot D plus C bar dot B bar plus D dot B bar. Okay. So we can remove this term D dot B bar which is available here. Okay. By applying consensus theorem, because this is X dot Y, this is X bar dot Z, this is Y dot Z. So if we'll remove it, we'll get to our RHS. Okay. So when you want to remove only one term explicitly, so from there you will get an idea that you need to apply the consensus theorem. Okay. So this is about questions about different kind of minimization. Okay. So go through the book to solve different questions regarding this minimization. Okay. Next we'll learn how
We
to.
don't have the book.
Okay, I will provide questions then. Okay, I will upload that in a classroom. Okay, so try to solve that and put your answers there. Okay. Next, Boolean function representation. Okay, so how to represent the Boolean function? So a function of n Boolean variable is denoted by function a comma b of n number of variable. What will happen? This function will be another variable. Suppose that will be equal to z. So any Boolean function can take only two values are possible. Either this z can be of 0 or 1. Only two possibilities are there. So these Boolean functions we can represent in many ways, like this truth table form, sum of product, product of sum, standard sum of product, standard product of sum. This is also called as canonical SOP. This is called as canonical product of sum. So out of all this, we learned about truth table form previously. We have done this. If we have suppose two variables a, b, and I want to find out this function a dot b, so we learned that how to represent it using truth table form. What will happen? This will be 0, this will be 0, this will be 0, this will be 1. Okay. So this is the first one, truth table form. So truth table form is one. A truth table is a table which will have all possible input combination and its corresponding output. Okay. So suppose I will go for a function. Suppose f is equal to ab plus a bar dot b. Then what will happen? How many possible combination input combinations are there? कितना possible combination होगा input का? I have two inputs A and B.
4.
4. 0 0 0 1 1 0 1 1. Okay. So F निकालना है तो क्या करना पड़ेगा? पहले A B निकालना पड़ेगा. Then A bar dot B. From that we can find the F. What will be AB? AB will be 0 0 0 1. Directly I am doing for A bar dot B. Okay. So you check it and verify. What will be A bar B for first one?
0.
0. Second one? 1. Third one? 0. Fourth one? Again 0. Because A is 1, so A bar will be 0. So 0.1 is 0. F is addition of these two. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus 0 is 1. So in this way we can represent this function. Okay. Same thing is applicable for 3 variable and 4 variable and higher variables. Okay. Next one, an important one. is the sum of product. As this name suggests, it is a sum of product terms. Sum of product terms. So product terms will be added together. Will be added together. Now, if we take a function of a, b, c. Okay. So suppose AC is a product term, B bar C is a product term, A bar B bar C bar is a product term. Then I am adding all this. So these product terms are getting added. So it is called as sum of product. Sum of product. Okay. Next, product of sum. As this name suggests, it will be opposite of SOP. It will be opposite of SOP. What will happen here? Here, some terms will be multiplied. Some terms will be multiplied. So what will happen to function of ABC? Any example of some term? Suppose A plus C multiply with, sorry, first sum term is A plus C. Second sum term is suppose B plus C bar. Third sum term is suppose A plus B plus C. Then they need to be multiplied. They need to be multiplied. So as this name suggests, from that name you will get an idea. Sum of product means product terms will be multiplied. Product of sum means sum term will be multiplied. SOP में क्या होगा? Product term will be added. POS sum terms will be multiplied. First of all, this 2 point clear. SOP POS.
Yes.
So if I'll write like this, suppose A B bar plus A bar C. So this is SOP or POS?
SOP.
This is SOP. Okay. Now take this example only. This above example. Now in this function, how many variables are present? 3 variables are present. A, B, and C. Okay. So if it consists of 3 variables A, B, C, in this product term, how many variables are present? कितना वेरिएबल यहाँ पे है? In
3.
this product term. नहीं 3 नहीं है, A, C खाली है ना.
2.
So how many are there? 2. Here 2. Here 3. So they are not in a standard form. So in a standard form, what happens? If I'll go for a ABC, then each product term should be consist of 3 variables. Suppose ABC plus A bar B bar C plus A B bar C bar. So it consists of 3 variables. So here also 3 variables, here also 3 variables, here also 3 variables. It is called as standard sum of product. Standard sum of product. Okay. So the number of input variable, that number has to be same in each product term. Okay. So it will not possible that suppose you will write AB plus B bar C plus AC bar. So again it is not in a standard form, because your number of input variables are 3. Here you are taking 2, here you are taking 2, here you are taking 2. So in a standard form, in each term, your number of variables has to be same as number of input variables. Okay. So you can see one example here for SOP, standard SOP, and for standard POS, this is the example. This is the example. Okay. So is it clear about SOP, POS, standard SOP, standard POS? What is the difference? So now suppose I will take an example.
Yes.
Just I'm writing F. One second. Is it in a standard form? Can you identify this?
No, sir.
Can't say.
Can't say. Okay. Why?
There are three input variables, but
You can see here in this expression, it consists of A, B, C.
No, sir, not.
Okay. So ABC means here 2, here 2, here 2. So it is not in a standard form. So it is only sum of product. Okay. Okay. Next one. So this SOP and POS, standard SOP, standard POS are very important. Very important. Now, what is the advantage of this? Suppose I will tell you to find out expression for this. So I want to represent this function. I want to represent this function. Okay. So if I will go, I want to write its truth table. I want to write its truth table. Okay. So what I need to do? It is easy, but it will be lengthier. First of all, how many inputs are there? Three inputs are there. A, B, C. So how many possible possible combinations will be there? If I have three inputs, how many? Eight possible combinations. 4041, 0011, then 01. Okay. Now, to write this function, can I write directly about this f? Can I write like this directly? What will be f? Is it possible?
No, sir.
So what to do? कितना यहाँ पे column चाहिए? If we'll try to solve it, first of all you need to find out a bar, then b bar, then c bar. Three columns. I'm not solving, just I'm writing. Okay. I need to find A bar, B bar, C bar. Then each column for this. So how many columns? Five columns. One, two, three, four, five. For each of these terms, one will be A bar, B bar, C. One will be A bar, B bar, C bar. One will be A, B, C bar. One will be A bar, B, C bar. Another will be A, B, C. Then you can write the function f. Then this pipe will get added. So this is easier. This is simple Boolean expressions you can find out, but it will become lengthy. This thing will become lengthy. Okay. So to solve that issue, we need to go for this mean terms and max term. So by knowing this mean terms and max term, without solving anything, directly I will be able to write this function. I will be able to write it as 0, 1, what I can directly able to write. Okay. So again we'll not able to finish this, so we'll do that in next class. Okay. So at a time stretch only we'll finish everything. So we'll do that in next week. Okay.
okay, sir.
So write your roll numbers in the chat box.